Hello, everyone. I'm Adam Okada from Beyond Clean, and I'd like to express my gratitude for you choosing to spend your Friday with the speakers and myself. You are 100% making our day, and for that, we thank you. The title of this conference is Assure, Be Sure, Sterility and Packaging in Sterile Processing, and it has been such a great day filled with enlightening dialogue from our subject matter experts, and our next speaker is here to keep this day of education rolling. Jerry DiBattista is the Vice President of Marketing at Porex. In his role, Jerry is globally responsible for marketing PTFE materials in all market segments. With over 35 years of technical industry experience and degrees in chemistry, chemical engineering, and a master's in business, Jerry is considered a materials application expert in multiple fields. With a strong materials background, Jerry has extensive experience in R&D, manufacturing, product management, marketing, sales, and business development. With multiple patents, numerous publications, and frequent speaking engagements, Jerry is considered a technical application expert in electronic, life science, industrial, and automotive markets. Today, Jerry is going to discuss why, over the years, more healthcare facilities have made the switch to autoclave sterilization containers due to their sustainability and safety improvements. However, these containers still mainly use disposable filters that generate waste and room for errors. So during this session, you will discover innovative reusable materials many healthcare facilities are implementing to improve cost and safety benefits associated with utilizing these autoclavable sterilization containers. You'll never have to worry about a blue wrap shortage again. I'm really excited for this one, so let's welcome Jerry to the virtual stage.
Well, thank you, Adam, for that introduction. Very flattered. That was a really nice intro. As Adam mentioned, today we are going to be talking about improvements in medical and surgical device sterilization using innovative materials to improve safety and sustainability of autoclave sterilization containers. It's an area that I'm really passionate about and strongly believe that can help the world be healthier, safer, and more productive. This is a preview of the slide that Adam already mentioned. I am the Vice President of Marketing and Business Development for our Porex Vertec PTFE product line. I lead a global team dedicated to collaborative working with customers, innovation with our customers across many markets, including the life sciences, which is the focus of this area today. I do have a degree in chemical engineering, material science, and a master's in business, and I've been in the industry over 35 years, longer than I care to admit sometimes. So, just as a preview, the surgical device industry continues to grow and grow pretty substantially. Certainly, last year during the pandemic and COVID, there was frankly a bit of a pause in surgical device industry as people stayed away, stayed at home, and didn't have procedures. The market had a bit of a pause, which was interesting. So now there's a lot of pent-up demand. And hospitals and surgeries are picking up pace fairly quickly. The market is still looking to grow at almost 10% annually between this year and 2028. So it is truly still a fast-growing market as more and more people select to have elective surgeries and other surgeries to improve quality of life. Sterilization still becomes a critical, absolutely critical step in ensuring that surgeries are conducted safely at the facility. So there's, as I said, the Grandview Research did a recent study. I suggest if you're in this market, this is a good study to look and to review. So as surgeries continue to increase, selective surgeries and necessary surgeries, believe it or not, on a given day, 1 in 31 patients acquire some kind of healthcare-associated infection. You would think today in 2021 that number would be less, but it still stays fairly robust. According to Health and Human Services, if you look to the left, in the United States alone, approximately 2 million patients suffer healthcare-associated infection annually. And believe it or not, about 90,000 people are estimated to die from those infections. And that's a staggering number when you think about it. The cost of these infections to hospitals, they estimate range between $28 and $45 billion per year to these hospitals. So the cost is massive, the numbers are massive, it hurts reputation, it hurts so many things. So this issue really has to be addressed further. So the challenge, certainly for healthcare providers, and especially for hospitals and clinics and even veterinary and dental facilities who do all of these surgeries, is to find a safe, cost-effective, convenient, and sustainable way to sterilize equipment. And it would sound fairly easy, but there are many options, and we'll review some of those here shortly. So the basic agenda of the talk today, we're going to go through some of the current sterilization options and go into a little detail, mostly detail in the steam sterilization and the options within there. But we're also going to talk briefly on some of the other sterilization options. Go into a deeper dive on why filtration is really the key to performance in these applications, and how that drives everything from sustainability to everything else within the application. I'm going to do a brief introduction into porous polymer technologies and why that's important in this market, in this application. And then we'll have a question and answer session at the very end. I do recommend, if you do have a question as I go through the presentation, to please type it in immediately, and then we will sort through those and we'll answer them at the very end. Okay, section 1 is current sterilization options. So this is a great link down below. The CDC has, in their infection control section, has a great guide to all kind of different sterilization methods. These are some of the most common, steam sterilization being the most common, but there are certainly others. Flash sterilization, ethylene oxide, or ETO, as it's mostly known as, hydrogen peroxide gas, plasma, peratic acid, ionizing radiation. This is gamma radiation, which is used. And there are numerous other methods like dry heat and several others. Most of these have pluses and minuses. Steam works great for many applications, but if there are electronics involved in the device, or if there are some temperature limitations on materials, then steam may not be your best choice. But for surgical equipment, typically steam is the method of choice. It's the most economical and most reliable. Ethylene oxide, ETO, is very effective. However, it is a toxic gas, and there has been issues with ETO in several areas. I personally live in the Atlanta area, and we had a few ETO facilities shut down because they were emitting ETO and causing issues with health around the facility. So again, you have to be very careful with this. Ionizing radiation or gamma radiation, again, that's a radioactive source using to sterilize equipment. Again, some negative annotations there, and certainly a lot to be worried about. So again, we're not going to cover all the other ones today. We're talking about steam sterilization and some of the features and benefits of that technology. So I'm going to go through a couple of the most common ways steam sterilization is used. The first one is, I would say, one-time use or open trays, and combining those two. One-time use are packages that are designed to seal around either a device itself. You can have just one part in there, or you can have a tray like shown in the picture with several parts in it. And then it's heat sealed typically or zipped around the device. And then it's put into an autoclave. Those tend to generate a lot of waste. Specifically, the packages are typically certain sizes. So sometimes a package goes mainly unused. And they tend to be fairly space inefficient. Open trays, believe it or not, that's very, very common still in the marketplace. They can easily be contaminated. Certainly when it's in the device, it becomes sterilized. You take it out. Any kind of airborne bacteria or anything in the air can certainly contaminate the device very, very easily. So it's definitely not a sterile barrier during storage or transportation to its intended use place. So, in a nutshell, patient health can be compromised using open trays, and the environment can suffer using one-time disposable solutions. Second, very common area is this, and she says blue wrap. It's kind of the industry term for it. This is a one-time use, typically non-woven material. The package or the unit that you're trying to sterilize is then wrapped in this blue wrap. I've seen this done in so many different ways. I care not to tell you. I mean, I've seen them use tape. I've seen them use open. I've seen them use nothing. It's crazy, the inconsistencies and between users and others who do the wrapping. Sometimes you get really pretty nice, neat ones. Sometimes they look like the photo on top, where they're very inconsistent. I kind of like to compare it to gift wrapping a box. Sometimes you get gift wraps that look so beautiful and perfect, and sometimes it looks like a 3-year-old did it. So it can have amazing amount of inconsistency. But towards the environment, it generates a tremendous amount of waste. These are used once, then thrown away. The inconsistency is pretty alarming. Sometimes, like I said, it can be wrapped very well. Sometimes it's not. Sharp equipment, if it's not handled properly in the wrap, can easily puncture or tear the blue wrap. So it's fairly fragile material. A scalpel or any kind of pick can easily go through it, and then any kind of sterile barrier you had is gone. Another problem is these things can have moisture go through them, especially if they're not sealed well. And then when you open up your package, it can remain wet inside. So it's definitely not a sterile barrier, even though the blue wrap companies will tell you that it has a BFE rating, bacterial filtration efficiency rating of 70, 80, 90, 95%. That assumes that the product is completely sealed off. Any kind of openings or crevices within it will reduce that bacterial filtration efficiency dramatically. Okay, next is sterilization containers with a disposable filter. These containers are designed to go into autoclaves. I believe the talk that's following ours is from Escalab, manufacturer of these containers. One of the industry standards of these containers. These are designed for autoclaves, and a lot of times they are designed specifically for specific autoclaves, so they pack neatly and efficiently. You can find these everywhere, and like I said, medical clinics, dental, veterinaries. They are typically autoclaved and exposed to saturated steam at 121 to 132 C for about 15 to 30 minutes under a pressure of about 106 kilopascals. So it's slightly above atmospheric pressure, and it sanitizes by eradicating any microbial life. So these are truly sanitized products. So this is really the method of choice for most hospitals and clinics. It's very efficient and very repeatable and very sustainable. As I mentioned before, this was a study that was done by Esculap a few years back. They did a study in the United States to see what kind of savings could happen from switching to blue wrap to a sterilization container system. And the summary was $16.4 million in annual savings, 180,000 hours. It takes quite a while to wrap these surgical packages, so a tremendous amount of hours of savings. And the big thing is how many pounds of waste that are reduced every year. You know, over 1.4 million pounds of waste that won't find its way into a landfill by going from blue wrap to reusable sterilization containers. So the benefit is very clear that this is probably the best way to use an autoclave system. So the challenge then becomes, okay, this is probably the preferred method, but there's a couple things, right? Number one, most of these still use a disposable filter. So the photo on the bottom shows a handmade one, and unfortunately, that happens when, especially during supply shortages, and if purchasing forgets to order these things or you run out, people can just cut it out of blue wrap or something else to put in the system. And it does happen. But these things are one-time use. These, or at least they're intended to be one-time use. So these filters are used one time and still thrown away. So yes, you do reduce a tremendous amount of waste by not having to wrap the entire package, but your filter is still used once and has to be replaced. Not only that, but it does have to be manually taken care of. So once these containers are done with their use for the application, they have to go back into some kind of facility or maintenance facility where they would replace these filters one at a time. So again, the key is that your weakest link is still here, your filter, because these filters will still have a bacterial filtration efficiency of that filter paper. So even though these containers are excellent for storing sterile devices and are easily to stack and you're very versatile, if you do use an inferior filter, you still have a risk of having bacteria enter that device through the filter media itself. Also, in the photo below, you can see how this one is wrinkled a bit. Certainly, it was done purposely, but that can happen with these filters. If the paper that they cut it out of has been folded and there's a wrinkle in it, that wrinkle, as you put it in the device, can be another break in the seal. And even if you do have a material you're using with a relatively high bacterial filtration efficiency of in the 90s, breaking that seal with a fold or a crease reduces it dramatically. So again, if you want to go to a sustainable solution and look at containers that are reusable, then shouldn't you think about going all the way and using filters that are also reusable? So again, filtration, as I mentioned, is really key to the performance. So what is the role of filter? So the filter in a sterilization container acts as a vent to allow pressure equalization during sterilization. And what that means is as the device or as the box is put into the autoclave, it starts off at a lower temperature and lower pressure. Once the autoclave is heated up, the pressure around the container starts to go up, which means that the pressure must equalize from outside and inside or you'll have expansion or contraction of that container, which can be a problem. So you need to allow the pressure to be equal inside and out. It acts as a protective barrier against microbes entering the container during transit and storage. And that's really critical. If you look at the photo on the right, as air can pass through, the blue arrow, see air passes through, but the material prevents bacteria, dust, dirt, liquid water, whatever that may condensate on top from getting into the container. So it's really critical. Lastly, the filter is critical for the performance of the sterilization container. The container efficiency is only as good as that weakest link, which tends to be the filter. So again, if you're trying to reduce bacteria or any kind of microbes within your facility, and the paper itself or whatever you're using as the filter has a lower level of bacterial filtration, that bacteria will get into your device. So again, I think I mentioned some of these already. Where does the problem occur? Now the photo here is a picture of a sterilization container. The fancy disc there with the wavy shaped is the holder. The little black piece is the retaining ring, and they're actually snapped into place very, very easily that way. The problem is that blue paper tends to be fairly fragile. It's extremely flexible, so it can create creases and wrinkles that can go through the whole system and create a failure in the seal. You can get very consistent filtration. There is blue wrap out there that has a filtration efficiency of 70% up to 99.9%. So, which one do you have? How do you know? Where is your product in that line? Do you even know? I mean, this is not always mentioned in the product portfolio. Assembly inefficiencies. Like I mentioned earlier, every time these units are used, they have to be disassembled, and then that filter has to be removed and replaced. And one of the things that is critical is that how are you ensured that that filter has been replaced? These are typically one-time use, and there's really no. There are some that have an indicator, but most of them don't to show that they've been used. And so, if there's no indicator to show, okay, this has been used, how do you know that it's not being reused multiple times? These products really are not designed to be used more than once, and there are facilities that use them multiple times, and that seriously compromises potential patient health. And I mentioned earlier, they tend to have a fairly low BFE rating, bacterial filtration efficiency rating, of less than 95%. So that means is if it's exposed to any kind of bacteria, 95% means it's taking 95% out, but that still means 5% of the bacteria is getting through that filter, which is, quite frankly, a scary number. Okay, so disposing of filters and blue wrap, it's, again, higher risk, higher waste. As I mentioned, it's very difficult to verify that the filter has been replaced. Even using blue wrap sometimes can be reused, and that's, again, a very scary proposition. Can easily be installed incorrectly. There's no indicator to say that, hey, it's properly put in. They are single use, and that's how they're intended to be used, and certainly that generates a lot of waste. And then again, the lower the BFE rating, the bacterial filtration efficiency rating, means a higher healthcare associated infection risk. So just remember those numbers go in opposite direction. The lower the BFE rating, your higher your hospital risk. So you want to have a super high BFE rating to ensure that your device, your container is sterile and remains sterile. during transit and use. So, switching to a reusable sterilization filter, these products are designed and can last the entire life of the device. There's products that have been tested up to 5,000 cycles. So, typically, sterilization containers used several thousand times it can last the entire life. The material can be repurposed at the end of life. The PTFE filters can be reprocessed. Certainly a tremendous amount of reduction of bio-waste, because anything that's coming from a hospital, almost anything will be considered bio-waste, which will reduce the impact on landfills and certainly on incineration. And here's the important thing: increased patient safety. The PTFE microfilters have a BFE rating of up to 99.9999%. So what that tells you is, out of every 100,000 microbes, one is getting through. That's it, not 5 of 100. So the amount of safety within your package is tremendous. And really the critical thing here too is that this is more or less a fit or forget type product. So once it's put in place, once it's fitted into the device, you really don't have to worry about it. So there's really no concern that the product was put in improperly. There's no concern that it's been damaged. The product is very robust. Unlike the paper, it's extremely hard to tear or puncture. It takes an enormous amount of force to go through the material. So overall, it's going to be better for patient safety, better for the planet, and it should help reduce costs in many ways to the hospital. This was just a brief example I put together of some potential cost savings for using the permanent type filters, reusable filters versus disposable filters. So there tends to be a cost difference on the initial upfront capital of these units. These units that contain the permanent filters will typically cost between $100 and $300 more upon purchase. And certainly that can scare purchasing departments, and they're trying to save money. Why would I spend so much money on a product that has a reusable filter? But if you start looking at the nuts and bolts of it, so you start on the left, what is the cost of these disposable filters? These things tend to cost between $75 and $200 per 1,000 filters, right? So if you're saying a typical product lasts between 3,000 and 5,000 cycles, that can be between $225 and $1,000 just for the filters, just to buy the filters. Cost to install the filters. This is an absolute hidden cost that nobody really thinks about. But these products do have to be changed out. Somebody has to handle them. Certainly, there's always a risk of damaging the containers as they become handled and the filters replaced. But if you look at 5 minutes to replace each filter at 3,000 to 5,000 cycles, and if you're paying the average hospital labor $15 to $25 an hour, that can add up to $3,750 to over $10,000 in savings by not having that expense of replacing the filter. The cost to procure, ship, handle, store, and replenish a stock of disposable filters. This is probably a low estimate, but $100 to $200 per container is easily the cost to do that. Especially these days where we're getting product tends to be difficult and there's shortages out there. Expediting fees and paying premium because products are not available. This could be a huge savings to the facility. Item C, the cost of filter disposal. Again, this is a tough one to estimate, but these have to be disposed, and anytime you're adding to the disposal costs of the hospital. There is, adding volume to it, there's going to be additional costs. So if we estimate 5 cents for these 3 to 10,000 pieces, that's another $150 to $500 over the life of each container. And then the cost of failed sterilization due to improper filter installation. Again, this is a really hard one to quantify, but it happens. Filters are installed improperly. Maybe it's reused. Maybe there was a tear in it because again, these are fairly fragile. They cut and tear very easily. Over the 5,000 cycles, if you just assume 10 to 20 of them are done incorrectly, you have to go back through the re-sterilization process, and it costs you maybe $25 to $50 to go through that process. That's another $250 to $1,000 of cost over the life of the container. So when you add it all up, you can cost you an extra $4,500 to $12,000 additional costs just because you're using a disposable filter versus a reusable filter. So as you can see, the extra $100 to $300 of upfront costs can easily repay themselves multiple times by making this choice versus disposable filters. So manufacturers have other material options for filters. The porous polymers, specifically the sintered PTFE, are the materials of choice, and they perform much better and last much longer than any other filter in the marketplace. Some of the advantages, disadvantages for the disposable versus the reusable PTFE filters. And I hope you appreciate my little graphic on the right. That's the pile of disposable filters that are needed for a container versus the one reusable filter for the life. So disposable filters are soft, they're easy to form, fragile, prone to damage and contamination, whereas reusable filters are very robust, very strong. They don't rip or tear easily, can't really puncture them, and it really protects the container sterility while it's being used. Disposable filters are susceptible to incorrect installation, which can reduce labor efficiency and product efficacy, whereas the reusable one filter is used for thousands of cycles and is really no reliance on service or accidental misuse because it's designed to be used multiple times. Disposable single-use nature creates enormous amount of waste versus the reusable, which is reduces material waste. And disposable filters lack of material reliability, consistency, and durability, increase safety risk. There are numerous amounts of brands out there, and really you don't know what you're getting sometimes if you're using off brands. The reusable filter is extremely hydrophobic. Water does not penetrate it. It's super chemical resistant. It's PFOA free. It has extremely high BFE ratings, like I mentioned, 99.999% BFE rating, and structurally it's extremely robust. So I have a real short video that I did a while back. It's a couple minutes. It just shows kind of a little demo of the disposable filters versus the reusable filters and a sterilization container. So we'll play that next, and hopefully this works.
Hi, and welcome to Jerry's Engineering Corner. My name is Jerry DiBattista, and I am the Global VP of Porex's Vertec PTFE Business Group. Today, we're going to continue on the theme of sustainability. If you had watched my last video when we were talking about some surgical equipment and using surgical wraps for sterilizing equipment, we talked about blue wrap and the problem with the waste of blue wrap versus using a sterilization box for sterilizing hospital equipment. Well, using a sterilization box itself is a great move towards sustainability. However, the majority of them on the market still use a disposable filter. So what you do is you would take the lid, put a filter in, the box, goes through the autoclave. When it's done, the lid is removed, holder is removed, and the filter is thrown away. Put a new filter in, repeat the cycle. Problem with disposal filters is they are very thin, very paper-like, and they can wrinkle, they can deform, they can be put in crooked. They take some time to make sure they're seated well, so it's a waste of resources there as well. And and they can be problematic. Another thing which can easily happen is, as I showed before, with the blue wrap, these things can poke very easy. As you can see, sharp equipment can go through the product very easy. Of course, the alternative is to use a Porex Vertec filter. These filters are designed to last at least 1,000 cycles or even more. You go right in place, set it, and forget it. So you ask, how do I know how long I had it in it? Well, another nice feature of Porex Vertec is that you can write on it. As you can see, very easy to write the date it was installed. You can even put change on whatever. You can write how many cycles it can go through very simply. And so you can imagine one of these can last 1,000, 2,000 cycles versus having to use thousands of these. And when you do that, you create a lot of waste, which has to be disposed of like medical waste. Well, that's it today for me, Jerry with a G.
Well, I hope you found that video helpful to show how it works. I do happen to have one of the disposable filters here, and then our Porex Vertec filter here, and you can see from here how much more robust it's completely self-supporting. Whereas the disposable filter just flops around like a loose piece of paper. Next, I'm going to talk a little bit about the technology behind porous materials. So we'll quickly go through this, and I will talk about how porous sintered materials are made. With a sintered particle, basically what you do is you take a fine powder of material, and you use a process called sintering, where these particles are fused to their neighbor, and kind of like taking a bag of peanuts or marbles, whatever, and putting them into a jar. The space that's left in between is the pore structure that remains within that porous matrix. So the pore structure equals the void space between the particles, and it becomes a real intricate network of omnidirectional pores. So it's not one directional, it kind of goes in all different directions. The sintering process itself is fairly straightforward. As I mentioned, if you see the photo on the left, you take some kind of container vessel, you fill it with particles. The particles are then subjected to heat and some pressure. The vessel opens, and what remains on the right is your sintered part, or whatever it may be. For the Porex Vertec, we make these in large logs, and then those logs are taken. So if you look at the photo here on the left, that is what we call a billet or a log of porous PTFE. That then goes into a skiving lathe. And so if anybody's familiar with a lathe, it's a piece of equipment that spins it spins the product around. Very commonly used in woodworking. So if you see how people make wood legs or round wood dowels, they're usually made in some kind of lathe. As it spins, we bring in a very, very sharp blade that then skives the product. So you get a very fine membrane coming off that log of PTFE. The best example I can use is like the veneer that people use for woodworking. So you can take like a tree log, a big log of tree, and then what they do is they shave a very thin layers off that log, and they use that for making furniture. So if you look at a wood veneer furniture where it might be made on plywood, you get a very thin layer of really nice wood they put on top, and that makes the whole furniture look like it's made from that piece of wood. That's the skiving process. So that's how we make our membrane. The beauty of it is that the log that we create is extremely uniform because the particles that are extremely uniform, they go in. The process is extremely controlled. So every time we make our product, the finished product is always going to be the same coming out. So it's extremely consistent. So what are the advantages of our Porex Vertec sintered PTFE? Extremely robust and durable, requires no supporting layers. A lot of membrane material require multiple layers to hold up that pore structure. Ours does not. It does not wrinkle very easily. It does not deform. It's extremely heat and chemical resistant. It withstands heat up to 500 degrees Fahrenheit. It's 100% pure, no additives, no coatings, so there's really no way to contaminate the device because it's extremely clean material. It's customizable in the sense that the surface is printable. We can make it in various thicknesses. For sterilization containers, it comes in three thicknesses, 0.25 millimeters, 0.64 millimeters, and 1 millimeter thick. The thicker the material, the longer the life of the material. And it can be customizable to your sterilization container. This is a common size. I think these are 190 millimeters, but they can be made in rectangles, they can be made in squares, they can be provided in strips, however else is needed for your application. There's no assembly orientation, so both sides are the same, so it can be inserted either way. It doesn't matter. The product's all manufactured in a class 100,000 clean room, and all our materials are USP Class 6 biocompatibility, and we do meet FDA requirements as well. So again, some considerations for sterilization container filters. For example, do you need a microbial barrier during storage? This is a question that is really sometimes not thought of. Is my filter a good barrier? And these sterilization boxes quite often are stored sometimes for hours or days before they're used. How often will a container be handled? Do you need a record of maintenance or installation date on it, right? Are you looking to reduce healthcare-associated infections in your facility? Are you looking to reduce waste? Are you trying to reduce rejected batches? Would you like to add a logo or other info? It's another thing you can do. As you can see here, hopefully, there's a logo printed on this one, the Porex Vertec, sorry. You can actually print your hospital logo. You can have other things printed on there if you want to do some kind of interesting marketing or whatever else. The material specs are down below. As I mentioned, there's 3 different thicknesses, all with excellent BFE ratings. And the last column is the water entry pressure, so you can see it resists a lot of water resistance as well. These things can go in feet of water without having water ingress through them. And my next to last slide. So what's next? How do I convert from a disposable to a reusable filter? So again, a word of caution, this is violated all the time, and I'm not going to get myself in trouble to say just go ahead and replace your filter with one of ours, because most containers are designed and certified to use either disposable or reusable filters. Not as common in the U.S. The reusable filters, much more common in Europe, but in the U.S. most containers are designed for disposable filters, and quite frankly, the manufacturer, they like to sell disposable because that's another income source for them. So, you really need to be careful when switching these out, and you have to make sure that the container really is designed for a reusable filter. Some of the newer ones now are truly fit and forget. They're designed with the filter sealed in place, and you cannot even remove it. So it is actually part of the lid assembly, and it is truly designed to last until you go through a normal maintenance cycle with that box, which you can. And a lot of manufacturers offer a standard maintenance cycle where they may replace seals, and then the filter would be part of that normal maintenance cycle. So again, please contact your manufacturer. Most of them do make them or have them. A lot of times they don't promote them that much, but they do have them. And we are reordering new containers. Really make sure you ask for the ones with the permanent filters. There are some options. Some of the manufacturers also have ways to change the filter housing that will actually make that container then suitable for reusable filters. So, or you can just replace the lid portion. So here's a typical lid. This would be the holder. There are actually some filter manufacturers that you can replace this in an existing unit and then use a more permanent filter. So I can't reiterate enough, ask your manufacturer you're buying from, or look around at other manufacturers and see what their options are for product with long life filters. So again, as I mentioned, ask your supplier. They do want to sell the consumable. So this sometimes is not the biggest advantage for them. Think back to the printers, the HPs of the world, where they would sell you the printer for a very low price, but then every time you had to go buy ink, they would charge you an arm and a leg for the ink. So luckily there are a lot of off-brand products out there that tend to drop the value of these filters, but again, much easier to use a permanent filter. There are some newer models out there that have been certified to use both reusable and disposable ones. So again, check with your supplier, and again, make the switch, because a little bit more upfront cost will lead not only to long-term savings of the filter media, but savings within your hospital in reduction of HAIs. I can't underscore that. It's really feel passionate about that our product really goes and helps saves lives, and that to me is more important than any revenue coming from our sales. I truly believe our product will help save lives at hospitals. And lastly, please understand the rules and regulations at your specific area. They do vary by state, so you know what you can and can't do. And down below, here's a couple links of some examples of reusable filter products from Medical Expo. They have quite a few that are reusable. And I think that is it. My email address, I actually have a few of them, but Jerry D. Batista, and you can actually write it out, filtrationgroup.com or fgc.com also works. So I'd be happy to take questions after. If we don't get a chance to get to them today, you can email me and I'll try to get to them. Okay.
Yes, absolutely. It is that time that we go through the Q&A, Jerry. So hopefully you can hear me. Let's get into the first one here. Why is the filter, and I think you covered this a little bit during the presentation, why is the filter disc a better protection from microorganisms than a blue wrap?
So, these filter media. So the blue wrap, has quite a very range of pore sizes within it, and so these pore sizes tend to be fairly large, and so can be fairly large. And so what happens is the bacteria, which is fairly small, can penetrate these filters. Again, the key thing to look at is your bacterial filtration efficiency. This is a test that can be run to show how much bacteria actually makes it through your filter. And again, it's critical to have something as high as possible because, bacteria, viruses, all that will penetrate at they're very similar size. So bacteria and viruses will penetrate at a very, very similar rate. So if you see something that says 95%, you think, oh, that's a great, 95% is great. It's still an A, right? In my math class, it's not an A in the medical field. 95% is not a good number.
Right, and we kind of know that with our audit rates and things like that. 98% still means you had 2 out of 100 that were bad. So we know we're looking for as close to 100 as we can, right?
Right. Absolutely.
This question is about the cost of relearning rigid containers. How long does it take, like if, say, a staff was to adopt these containers or the reusable filters, how long does it take staff to learn that new system? And is there, additional cost involved in retraining staff to use them?
That's a good question. I don't think there is because there's really not much to do with these. I mean, they're basically fit and forget. So, whatever your process is after they're used in surgery, it's one less step. You do not have to replace the filter. So, if there's a cleaning procedure or any kind of other procedure that you do after, it can be done exactly the same way. Without the step of changing the filter.
Right. So here's another question for you. Most leaders know employees will not write the number of uses on the filters. So how can we confidently know we have not gone beyond the usage recommendations?
Yeah, I mean, that's a tough question. Again, these filters really are designed to last as long as the system. Some people feel like they need to replace it after a few thousand cycles. We've had suppliers run these for 5,000 cycles. So if there is any concern there, I would recommend that maybe at a certain interval or certain date, like maybe once a year or once every 2 years, you just do a wholesale change. And if there is a maintenance cycle you do on your containers, for example, changing the seals or gaskets or just doing a much deeper inspection, then that may be the time to do a filter change as well.
All right,
okay?
Absolutely.
And of course, the lid of it is fairly open, so usually if you take a lid and if you write on the filter, you actually can see it through the top of the lid. So if there's no date on it, if you do not write the date on it, then it's pretty visible that it's not written on there, right?
Yep, absolutely. All right, so let's see. Are the filters validated to go through the cart washer?
Oh, gosh. That's a good question. I do not know. You really have to ask your manufacturer of the container for that. That's not a test that we would run, but if you talk to an Escalab or a Genesis, they'll be able to tell you that. That's a test that they have to run.
Okay.
But I don't see a big problem with that, though, quite frankly. The material is pretty inert to everything. So.
Yeah, I would imagine if it can go through steam, it probably should be okay going through the water in the cart washer, but I guess you would have to check with the manufacturer to make sure.
Right.
What happens if one of the filters gets contaminated? So let's say it gets sent down with bloody instrumentation and some gets on the filter. Is that filter done and you have to replace? Or is it able to be cleaned?
So again, the filter is very resistant to pretty much anything. So it can be cleaned. Again, I would ask your manufacturer for the recommendations on that. But I would say that certainly going through the steam autoclave is a good cleaning process itself, right? So depending on the level of contamination, again, you have to make your judgment call on that one. But again, the filters. So if the filters are designed to be put in there permanently, then again, I would ask the manufacturer. Most of the containers that are on the market today, you can replace these filters. So again, if it's contaminated pretty badly, then it's probably best to replace it.
Okay, gotcha. So here's a question on mechanical valves. Are mechanical valves better than PTFE filters?
You know, there's always been a debate about the mechanical versus the porous material. You know, mechanical valves, which you have to be careful about, is that when they open or close, you know, they're open to the environment, right? So certainly in the autoclave, when you have a valve opening or closing, you know, that's one thing. But because you're in a sterile environment in the autoclave. But if these valves, you know, if they do have to open or close when it's outside of the container, then you really have no filter to allow air to go in or out, right? So again, they're out there, but you know, to me, having some kind of filter to ensure that any kind of air movement in and out of that container is filtered would give me a better peace of mind.
Gotcha. Very good. Have these been tested for extended cycles or higher temperatures? We see a lot of different kinds of cycles coming through nowadays. Have these been tested for those types of things?
You know, we'd have to understand what that is. You know, the nice thing about PTFE is that it's actually rated to run up to 260 degrees Celsius, 500 degrees Fahrenheit. You know, we use it in applications that are very extreme. I don't see any issues at running higher temperatures or higher cycles. I mean, certainly unless they get up to that temperature, and then you have to really start worrying about your seals and other things within your container as well. You know, there's not many more materials that are more robust. You know, PTFE is the same type material that coats you know, frying pans, right? So it is extremely robust type material. So I don't see that as a problem. But you know, if you do have certain temperatures and cycles that you're interested in, you know, you can shoot me an email and I can get back to you, because I'm not sure what that is, right? Is it, you know, how much higher than the normal cycle that are you talking about temperature-wise?
Gotcha. All right, so there were one more. And if you guys have more questions, feel free to enter them in the Ask a Question section. I will highlight it on your screen for you here. Jerry is here. He's an expert in the field, so please be sure to ask him questions if you have them. Have these filters been tested for the autoclavable carts? So we see these new case carts that you could actually stick in the sterilizer and autoclave. Have these filters been tested with those?
I would assume that they have. Again, the manufacturers do the ultimate testing, right? We provide just the part that goes into it. So certainly, if the container is verified for it, then our product would be as well. But I would see absolutely no issue there.
Awesome. And yeah, especially if that they could go through a cart washing system like that, that would be massive cost savings right there. That you could actually sterilize all these things and no filters at all.
Absolutely.
Yeah. So really game-changing stuff. We are running out of time here, so I'll go ahead and finish up this session here. But thank you, Jerry, so much for critical insights. Really game-changing stuff that we're talking about in this session. So really, really fascinating. If you guys have any questions we weren't able to get to, you can connect with Jerry via email or LinkedIn. His email is on the screen for you there. Both options can be also found in the speaker bio tool on the right-hand part of your screen. As a reminder, there will be a short 15-minute break before the next session. We're glad you're here, and we'll see you back here real soon.
Thank you again for hosting. It was my pleasure.